Okay, so the last of the four conic sections that we're going to be looking at are hyperbolas. And so for the definition, a hyperbola is the set of all points in a plane, the difference of whose distances from two distinct points, which are the foci, is a positive constant, And so as you're going through and taking a look at a parabola, okay, then what you've got is, first of all, they could be orientated either way. They could be vertically opening or horizontally opening. All right, and we'll take a look at that a little more closely here in just a few minutes. Okay, but in order to get the points, the differences, right, of whose distances from these distinct points is a positive constant, right, is a positive constant. So you've got 2 points, your focus, right? So these are my 2 foci. Okay, then to get those points, right, the difference of the distances from those have to be the same value. Okay, they've got to be the same value. All right, so like in other words, if this point right here, okay, has the distance from this focus and the distance from this focus, the difference of those two, okay, would have to be the same. So yes, the further I get away from this one, right, this one also increases in length away, so that the difference is the same constant, the same positive constant. In other words, from here minus here could be 5. Well, when I come up here, here to here minus here to here is still 5, and same way the other way around, and same way down here, right? So from here to here minus from here to here is still 5, right? So you've got one on each side. Okay, so that's what that means. Just some different parts and things here to look at. So if you're talking about, let's say we wanted some distances here to look at. Okay, so first of all, as you're looking at this, okay, we're talking about these 4 corner points that we could be looking at right here when your asymptotes intersect right here, okay, to create this square, right? And so when you're looking at these, the distance A, right, is from this point, right, which is your center, okay, up to this point, which is a vertex. That's the distance of A from here to here, okay? Your distance of B, right, is from here, from this vertex out to this point, right, out to this point, okay? And the distance of C is going to be the distance from this center out to the focus, right? Okay, so A, center to vertex, B, center to, or excuse me, C, center to focus, and then B is going to be from here out to this point, this corner point that's formed by this square of the asymptotes. All right. Let me see what else we got here. And so as you're looking at some of these points then and other parts of it, then we can come to these equations, which are the equations of the standard form for the hyperbola. Okay, so once again, h comma k is still my center, right? And just like with an ellipse and a parabola, they can be oriented vertically or horizontally, either one. And so how do we determine which one is which? Well, unlike an ellipse, there's not a plus here, it's a minus, right? And so whatever value is here, okay, that's always going to be your A. All right, that's going to be always going to be your A. And so if the X comes first, right, then it is horizontally oriented. And if the Y expression comes first, then it is oriented vertically. Okay. And by the way, I kind of passed over some of these words. The transverse axis is the one that goes through the focus and the center, right? okay? And then the conjugate axis is the one that's perpendicular to that, that doesn't actually hit the hyperbola in any spot, okay? All right, so transverse axis is the one that we describe orientated as horizontally or vertically. So it's all based on which one comes first, right? Not which one's bigger underneath or anything like that, okay? So whichever one is behind the minus, okay, you look at the other one. The one that comes first is how you determine what the orientation of the parabola is going to be. All right, some other things. The vertices are A units from the center, and the foci are C units from the center, so that's kind of what we talked about up here. And this equation, C squared equals A squared plus B squared, is a relationship between the A's and the B and the C. All right, and if the center of the hyperbola is at the origin, you don't need your H and K here. It takes on these forms. Okay. Also, we have a portion down here that's talking about the eccentricity. So the eccentricity of a hyperbola is equal to the square root of A squared plus B squared over A. All right. So this is calculated a little bit different than the eccentricity was calculated for the ellipse when we had that. And just to get a general idea about eccentricity across all of the conic sections, if the eccentricity is 0, you've got yourself a circle. If it's between 0 and 1, we have an ellipse, and we talked about that. If the eccentricity is equal to 1, then you have a parabola. But when the eccentricity becomes greater than 1, we get a hyperbola. And then for infinite eccentricity, that's when you get it all stretched out to be a line. All right? And so that's just kind of some statements that help you to kind of understand what eccentricity gives you. Okay? And here's the formula for eccentricity in a hyperbola. All right. Okay, so when we turn it over, just like for all the rest of the conic sections, I've given you a chart from a separate resource, which also kind of gives you all of the things that we talked about on the other page. So if it's a horizontal orientation, then the x coordinate or the x expression will come first, followed by minus the y expression. Once again, these have to be set equal to 1 to be in standard form as well. Centers HK. The vertices are H plus or minus A, comma K. The foci are H plus or minus C, comma K. Then you have the equation of the transverse axis, the equation of the conjugate axis, and also how you can write the equation of the asymptotes. So for a horizontal oriented one, it's y equals K plus or minus A over B, and then times x minus h. Okay? So again, here's my ABC relationship. Here's the main one that we're going to use because we can get A and B from the equation. But again, C is equal to the square root of A squared plus B squared. And then for when the orientation is vertical, then it just kind of flips to adjusting the K coordinate, right? But it's the same kind of idea, but it's just the other coordinate that's kind of adjusted for this. And the asymptote, the fraction flips, and this, of course, is the same. All right. So again, we're going to use this to kind of answer questions in the following format. Okay, so it says find the standard form. Okay, find the center, vertices, foci, and asymptotes. So once again, 5 things that we're asked to find. So the first thing we're going to do is take this equation. It's in general form, I would say. Well, maybe not exactly. Okay, but we need to take it and turn it into standard form. So how are we going to do that? Okay, first of all, I need to take a look here and see which one of my variables is going to be in the first fraction. And the way we tell that, okay, is the way that we kind of take a look at that is to see which one of these is going to be oriented right here. First of all, in a positive direction, right? Okay, so which one of the coefficients is going to be positive, and then also we can tell by looking at which one of these here is going to be also the biggest one, because when we come back and take a look at this, if we're relating, right, the A and the B, if you go back over here and look at this and relate the A to the b part of this, then when you're looking at a and b, okay, the whichever one's bigger is what I'm getting at. Is doesn't really make a difference here as to which one comes first, right? So we were looking at ellipse, the one that was the biggest one, right, determined which one was the A or the B and whatnot. But in this case, okay, that doesn't make the difference here, right? And so again, when we're looking at this one, okay, we want to group all of the Y's together first, right? And then we'll group the X's together second. And so when we go and do that, it'll look like this. So it'll go 9y squared, and then I'll put plus 54y, right? And then after that, we'll go with the x's, minus x squared, and then we'll go plus 2x, okay? Then we've got the 62, and we'll move that to the other side, minus 62, okay? So there's my first step. Okay, so then after that, what I can do is I can factor a 9 out of the y coordinates, or the y expressions here. So this will be 9 open y squared plus, take 9 out of that, and that'll make 6y. Now, while I've got my parentheses open, I'm going to go ahead and complete the square, because remember, I'm trying to get it into this form, right? Trying to get it into this form. And so in order to do that, I'll half this to 3 and then square it. So I'm going to add 9 here, right? And we also need to complete the square on the other one. So that's going to be a minus, okay? And I'm going to open a set of parentheses. Now, remember, I have to factor this minus out because there's a minus between the expressions here in the general form. Now, when I do that, that's going to be x squared. But it's not going to be plus 2x, it's going to be minus 2x. So that's going to change the sign of all the terms that are within the parentheses. So now I half that to -1 and square it to +1. So I'm going to add 1 there to complete my square, right? Equals. Now there was a -62 over here, but remember, I've got to make the adjustment of what I added or subtracted in order to keep it equal. And so what I need to do here is I added 9. But I didn't just add 9, I added 9 times 9. So that's plus 81. And here, I added a 1, but I really added a -1 because I got to take this into consideration here. So I'll do -1. All right. So from here now, we can go ahead and factor. So this will be 9, and this will be y. And that's plus 3 close squared, right? Let's see, minus. And we'll go ahead and factor that as well. And then that's going to be -1 there. And this is going to combine together and make 18. Okay. All right, so at this point we're getting closer. And so from here now, remember, to be in the standard form, this has got to be set equal to 1, right? So I want to divide everything here by 18, 18, 18, and 18. And so once we do that, that will reduce down and become this, y plus 3 close squared over. We'll have a 2 on the bottom here, minus, and from here there's nothing to really cancel out with, so we'll have x minus 1 close squared, still over 18, but on this side we have 1, which is what we need. Okay, so now at this point, okay, I can go through and start to write in all the things that they've asked me before. But before I do that, I need to make sure that I can get the values of a, b, and c, because we'll definitely need that. So we'll need a, b, and c. So the value of a, okay, is going to be the square root of this number, because a squared is there. All right. So the square root of this number is square root of 2. Okay, so we'll leave it exact like that. Okay, I'm going to need the square root of this number and square root of 18, so b is equal to square root of 18. But I need to put that in a better format because that's also the square root of 3 times 3 times 2. So we'll go ahead and call that 3 square roots of 2 is probably the best form to put that in. All right. Now I also need to find the value for c. And remember, c is square root of a squared plus b squared. So c is going to be equal to the square root, right? The square root of square root of 2 squared, which is 2, right? Plus, let's see, 3 square roots of 2 squared, which means we're back to 18. Okay. So really with this, when you're trying to find c, it's just the square root of whatever these two numbers here are. Okay. And so that's the square root of 20. But then that is square root of 2 times square root of 2, square root of 2 times 2 times 5, which we know now is, pull a pair of 2's out of there, 2 square roots of 5. So my c is 2 square roots of 5. Oops, not 3. We need 5. Okay. Okay, so those are my 3 values of a, b, and c. So notice they all are square root numbers, which is fine. I'm going to leave them like that so they can be exact instead of decimals. And then so from here, I'm going to use those values for a, b, and c in order to find the rest of the things that they've asked me for, like center. May not need to incorporate it for center because center is h and k. All right. And so make sure that you're using the correct side. This is a vertical orientated hyperbola. And so my center is going to be, remember, the h is always with the x and the k is always with the y regardless of how it's oriented. So my h is with the k, so that's going to be 1 comma negative 3. All right, 1 comma negative 3. I've got to find the vertices. Okay. And so the vertices are going to be h, comma, k plus and minus a. So it's going to be h, which is 1, comma, k plus and minus a. So my k is negative 3, and it's going to be plus and minus. And I'm going to go ahead and leave it in this form because of the fact that my a is already a square root number, so I'm just going to call that plus or minus square root of 2. So we don't have to take that out and make that 2 separate decimal coordinate points. Okay, so you can leave it just like that. Those are your vertices. Let's try the foci now. And of course my foci are h, comma, so go ahead and write that in as a 1, comma. And it's going to be k plus or minus c. So my k is negative 3. And it's going to be plus or minus my c. And of course my c is 2 square roots of 5. And once again, since it's a square root number and not a whole number, it doesn't really benefit me too much to be able to write those as 2 separate points. So we'll leave it just like that. Now we've got to do the asymptotes. All right, so my asymptotes now are going to be y equals, all right, and it's y equals k, and remember my k is negative 3, so we'll have negative 3 there, and it's going to be plus or minus. How's it going? Oh. All right, so again, it's y equals negative 3 plus or minus. And the first fraction that we come to is going to be a over b. It's a over b. So the a is going to be on top, and the b is going to be over the bottom. And then so that's square root of 2 over 3 square roots of 2. The square roots of 2 will cancel, and then that fraction just becomes 1/3. All right? And then inside the parentheses, we've got x and then minus h. All right? So that's minus 1 And so though that will be your equations of the two asymptotes, the one with plus this and one with minus this. All right? So like I say, just keep your charts in front of you, and that will allow you to go through and answer the things that they're asking you to find on hyperbolas. All right? That's it.